Okay, it's almost 11, so I just want to kind of get started here. So we're going to have a couple student presentations today, a couple announcements before we get to those. Um, so there's a student's presentation sign-up sheet, and I'm signing times to them now that we're getting a little, we have that I know when people are. So again, I just assigned students that are presenting today 10-minute slots. Um, a lot of people have signed up for the final exam time, which is Tuesday from 8 to 9:40. I thought we could start at 9 because I didn't think many people want, but it's a very popular time apparently. We're gonna have to start at 8:30 on Tuesday and go to 9:40. I've signed everyone a time slot there. I gave everyone a random number and assigned you a slot based on that random number because I don't need the random numbers anymore. So um, okay, so everyone has a time slot. Then we have a couple people zooming on Sunday here. So just pay attention to that. Um, we are going to have the CIS showcase on Monday afternoon. I'm not having you necessarily present there, but if you want to present, you certainly can there. One of my classes, the architecture class, they're required to do their Raspberry Pi presentations, and the other class we're doing extra credit here. I don't think extra credit's going to be a great motivator for any of you right now. If you think you need extra credit, I can give you extra credit for presenting there, but I don't think we need a lot of extra credit right now in that class. But feel free to, even if you don't want to present, make sure you come there. We'll be recognizing graduating seniors, and there's a number of those in our class here. And it's always nice to see all the projects that are going on. So that's again Monday at standard 4 o'clock time here. Um, just a quick recap. So I've been trying to get caught up with grading. I'll finish up grading soon. Let me know if you see any problems with my grading. Sometimes I do make mistakes, as was pointed out earlier today, and I'll try to fix those. I was just grading or starting to look at the Unit 14. If you remember for Unit 14, we had all these NP complete problems, and people were trying to tie these together in different ways there. So I just want to show you what I was trying to get from this because each of you picked a problem, tried to show a problem that reduces to that problem, and then a problem that your problem can reduce to. And what that tends to do is make a kind of map here showing that all these problems are the same, basically. And again, this is the map from this class. It's not fully connected. In reality, it would. But again, we did not do all the problems here. There was a bunch of problems we did. And we didn't assign who was doing what problem. So you can do more of this. But you can kind of see here that, let's see if I can from one problem you can reduce to another problem. That problem you can reduce that. You can reduce that to SAT can be reduced to SAT3, and we can do all that sort of stuff. So basically, you can show that the idea is that if you can solve any one of these problems in polynomial time, there's a polynomial time conversion from any one of these problems to another one, and so you could solve all of them. From class, we still have a couple hanging, ones out here. The graph ones, traveling salesman ones, all those longest path ones, those are all closely related and they're tied together. It's a little harder to map like convex color do that, but again, there are maps that tie all these together. So I just want to show that you did an amazingly good job of bringing a lot of these together in this. So I was impressed with that. All right. Oh, did I have a spot for you to share your links for this? Maybe we'll do that on this. Do you guys have presentation links or something like that that you want to share? Or I don't know, where, first, I didn't know if you were doing a presentation. Are you just gonna do a paper or are you just gonna talk or?
Yeah, I'll just be like reading off my outline.
Okay, that's fine. Okay. Um, So let's do that. So why don't we start with Johnny here? You can close that and that. That. Okay.
Everybody, so I chose to do my paper project on the new programming language option. And specifically, I'm going to be focusing on TypeScript and Angular. We touched on TypeScript a little bit, but I don't think we really explored it a ton in this course. So again, I'll be reading off my outline for my paper. It's not complete yet, but most of the thoughts are there. Um, so many people get lost in the forest of programming languages, and understandably so. Whether your focus is machine learning, embedded software, web design, there are many options to choose from within each of these categories. One distinction I've noticed a lot of confusion over is the difference between like JavaScript and TypeScript. It's subtle, but the difference is there nonetheless. So in this paper, I'll be exploring the TypeScript language in depth, pros and cons, what its best uses are, and also what frameworks and applications it's used in. So it's helpful to think about TypeScript as like an improved version of JavaScript. It improves on JavaScript's limitations and sort of shortcomings. The defining feature of TypeScript would be its static typing, which means that TypeScript enforces its variables to be declared with a type before program runtime. Some of TypeScript's strengths, again, its most notable feature is the static typing. One of the things that works great for is large scale applications, mainly because like type errors and things are checked before runtime. It's a lot easier to catch those early on in the development process rather than having those propagate like later on in the process where they're a lot harder to get a handle on there. Um, so the fact that they're great for large scale applications kind of leads me to my next point about frameworks, which TypeScript is used heavily in. There are a lot of large like front end frameworks such as Angular, React, and Vue, which all use TypeScript. They're all JavaScript frameworks, but they all can use TypeScript and are, I think, mainly used with TypeScript. Angular specifically is praised as a great avenue for large scale industrial applications. For example, Delta Airlines, Gmail, PayPal, Adobe, YouTube, Netflix, and IBM all use Angular and TypeScript in their services. So again, these large scale kind of industrial applications where there's a lot of users and it adds a lot of ease of expansion, I'd say, and it just is able to handle those large scale tasks. Some weaknesses of TypeScript would be the fact that there are more moving parts because of its type checking system. More things can go wrong just because there are more error messages to parse through. So because there's more error messages at the start, it can be easy to confuse those and kind of get in the weeds on those. But I think in the end, it evens out and it's worth it. So in short, TypeScript provides peace of mind for programmers when they're developing because it forces things like type error checking to be completed at the start of the process so that there's no error propagation down the line that are more difficult to resolve. So that's it for me. Any questions?
So, you, you said these frameworks, that's why I didn't quite understand. So like the frameworks like Angular and React, because I program with React with TypeScript, but can you also do React with JavaScript? Did you learn? It sounded like you said you could. They were written in JavaScript, right? Or
Well, I mean, TypeScript is compiled to JavaScript
Right.
in the end. So I think technically, yes. I know for, I believe for all three of those, you can use them with JavaScript, but I think it's kind of meant to be used with TypeScript. Yeah,
Yeah.
yeah, yeah.
What, what are you teaching? Are you in web design now, or what are you? Do we teach any of these frameworks?
Not that I know of. I'm I'm not in the web design class, but I'm doing like independent study with Chris there for web design.
And which framework are you using for that?
I'm using Angular. Yeah. I don't think they teach any, or no, I think they use React actually in the web design class. I think Chris mentioned that, but again, I'm not 100% sure. Yeah.
So how did you, what kind of sources did you find? Because I mean, when you're doing more of a theoretical or research stuff, it's easier to kind of find what I would say like peer reviewed or good quality sources. But I always think it's a challenge when you're doing something like TypeScript, because there's so much information out there, so many websites and that sort of stuff. So what kind of sources did you find that you thought were good quality for this?
Yeah. So I first went to TypeScript's like official website,
Okay.
and they have a lot of documentation and good descriptions of like its uses and why certain things are certain ways, such as the error checking, before runtime there. Um, that explained a lot of how like it's compiled to JavaScript and how they like can work with those frameworks. And then I also found just some good articles explaining like differences between TypeScript and JavaScript and other web um, languages. So yeah, those were good sources I found too. Yeah.
Did anything surprise you? Because I assume you've been working with TypeScript now in your independent study. Did you learn anything surprising in this research?
I think it surprised me how many or how widely used it is for as many companies as they are. Like I didn't realize it was used by all those companies until I was doing this research. I had heard that it was very popular for like those industry large scale applications, but I hadn't put any names to it.
I think, I mean, a lot of times some people will reference like it's a website in JavaScript, and it's really a website in TypeScript.
Sure.
But it is technically in JavaScript because you're compiling. But I think a lot of times when people just say it's a JavaScript website or something like that, they often mean TypeScript.
Sure. Yeah.
That could be why yeah.
Yeah. And all those companies I mentioned, they specifically use it with Angular,
Okay.
that framework. So, and that provides, there's a lot of about Angular that I still don't know, but it's component based like React is. So it provides a lot of like reusability. So you're not having to write a bunch of duplicate code for these big applications where you might need to kind of recycle functionality.
Yeah, I've been looking at you took the mobile apps class, I think, didn't you?
I haven't, no, not
Oh,
yet.
okay, are you good? Yeah. So in that class, we do Flutter for 3 weeks.
Yeah.
For the last 8 weeks. And that's very component like. And in the past, I haven't compared it much to like React or Angular, but I think this next fall I teach, I think we're gonna try to maybe do more comparison, because again, that's very, you can make components and you do some reusability.
Yeah.
I think I'm gonna try to.
And Flutter isn't web-based, right?
You can't, I mean, Flutter is, from Flutter, you can create apps, or it's a higher level thing, so you can create
Okay.
things, you can find it in Flutter, and then you can build down to web or Android or
Okay.
iOS. So it's one of those higher levels.
Yeah, I've been kind of wanting to check that out.
Okay, sounds good. Any other questions? All right. Okay.
Sounds good.
Great, so looks like you're up next. And apparently I did schedule Kristen until 11:30, so you have been off for a long time.
talk about generics and how they can enforce type safety and allow for reusability. At the core, generics let us write reusable code that works with any data type. So instead of writing separate methods or classes for each type, you can write one version that can handle multiple types. This means less code to maintain and fewer mistakes because Java catches errors at compile time instead of runtime. So if you were to make a box class in code, you would need to make a string box for strings, a number box for numbers, and like a book box for books or custom objects. And that would require a lot of repeating code. However, with generics, you can write just one box class with a T parameter, and this tells the computer that this box can hold any type of object. It just needs the type specified when it's used. And the T parameter holds the data type, which you specify when you need to use it. This is a Python example of just a generic method. This function returns the first item in a list, which can hold any type because it's generic. T is the type variable, and the function expects a list of items, all of type T. The return type is also T. Return items 0 returns the first item in a list. When the function is given a list of integers, it returns the first integer in the list, which is 10. When the function is given a list of strings, it returns the first string in the list, which is A. So that's that output. Type hints in Python are a way to indicate what type of variable it is, function argument or return value is supposed to be. And they're totally optional, but they help with readability and catching bugs early. So this is like how generics is used in Python. This is a Java example of the generic method. And this generic method works with any data type. The method show type and value uses type parameter T to accept any input type and prints the formatted data type and value. The main method tests this method with different data types to prove that this works, showing the same generic method can handle the different data types. We have an integer, string, a double, and a Boolean. So the benefits of generics are that they help avoid duplications. You don't need to write multiple versions of the same code for different data types. They increase flexibility, meaning the same code can handle various types without extra work. And lastly, they make your code type safe by eliminating the need for casting. So if you have a list of strings defined from a generic list and you attempt to add an integer to that list, Java will catch that integer is not a string. You will then get a compile time error, which is much easier to handle than a runtime error, and therefore it makes the code easier to maintain. Downsides are in Java, generics don't work with primitive types like int and char directly. So when creating arrays with generics, that can also get tricky. You cannot create an array of generics in Java due to type erasure, which removes type information at runtime. Alternatively, you can use a list T with a type parameter T. In Python, there's no runtime enforcement of the types. You can still pass in any data type, even if it's not what you hinted at. So while generics can help, you still have to be careful and rely on your tools to catch mistakes. To wrap things up, generics are a great way to write reusable, flexible, and safer code. Java and Python do them in different ways, but the goal is the same, to write code that works for more than one type without repeating yourself. And once you get the hang of them, they keep your code neat and efficient. Question?
Obviously, if you use generics to write generics, because here's where I'm coming from. I'm old, and so when I learned the programming for a lot of my life programming, we didn't have generics. And so when I sit down to program, I never say, oh, I can make this function generic. I never think of that until later. At some point, sometimes later on, where I go, oh, I should have done that. I'll come back and make it generic. But my default is never to just make a generic stuff. So I was just wondering, have have you used it much or, after this, will you
Yeah.
use it more?
I've used it like in Java, but unless I like can like really plan ahead and know what I'm going to do with the program, like I probably wouldn't start out using it unless I knew I was going to like reuse the same method a bunch of times.
And I see it more like, in my mind, where I see something similar to this, is like in game design where you have, often you'll have a hierarchy of classes there, and again, you've got child classes and parent classes. I often write a function that'll accept a parent class, knowing that I will be passing in different types of children into that. But again, even when I do that, I don't think, oh, I could just make this generic there. So I'm interested to see, if you use it more going forward after.
Mhm.
Okay, let's do sources. So what did you find was sources for this?
So I used quite a lot. I think I had like 8 sources in total, but the one that I used the most was this article from Medium, and it's called A Comprehensive Guide to Java Generics Enhancing Code Reusability and Type Safety. And it just kind of like laid out all of the main topics. And it didn't go like too into detail, but it was just like, here's this thing, here's like a little explanation of this. And it was just like the one that I referenced the most, like in the big picture.
Where was it from?
Medium.
Okay.
Mhm. And then there was like a Geeks for Geeks article too. That was one that I used a lot. Um,
So, Python stuff. So yeah, so for Python, I mean, in my mind, since Python doesn't do really type checking, every time I write a function in Python, it's basically a generic, right? Is that how that works?
um, I guess, yeah. I think the way that they got around that was the type hints thing,
Right.
which that one, like, it took me a while to figure that out, but it's just like, it's just this optional little, like, you can tell it and then it'll catch the error.
Right.
So you
Okay.
kind of have to, it's not like Java where, like, I guess it's Java's like, it'll catch it right on compile time, but like Python, you have to help it out.
Right.
So,
All right. Other questions? Okay, I have a nothing. You gotta get listed on Zoom. Okay. Kristen, do you want to share your screen?
Yeah, I can.
Okay, let me stop sharing this and have you share. I'm gonna turn your volume down just a little bit too. Okay, see if you can share your screen.
Do you see this?
Yep, we see that.
Okay. It didn't work. I'll just have to do it like this. Okay. So this is my presentation on my final project, and it's about programming language foundation and the feasibility of a self-aware AI architecture. The big question when I started this, if we ever build a machine that truly self-aware, not just acting smart, but actually reflecting on itself, well, what kind of program language would it need to do that to make that possible? So first, what do I mean by self-aware AI? I'm not talking about just autonomy like a robot navigating it by itself. I mean an AI that can look inward, represent its own state, and even question or modify how it thinks. It would be something like having an internal self model, a piece of software that lets the AI notice its own errors, reflecting on its decisions and adjusting itself over time. Think of it like an AI that only makes choices, but also asks itself, why do I just do that? This is inspiring by cognitive science theories like global workspace theory, which treats conscious as a broadcasting hub for integrating thoughts and integrating information theory, which emphasizes dense interconnection and unified information flow. Um, Now here's something. So here's a twist. I agree that building this kind of AI depends not just on clever algorithms, but on choosing the right programming language feature. In other words, the language of thought for conscious machines might literally need to be a language that supports examining and writing its own code. Most popular languages we use, like Python, C++, or Java, aren't built for that. They're great for task-driven autonomy, but it's not for self-modification or introspective. So I focus on four key features that would support machine self-awareness. Um, this is super hard to pronounce. Um, homos homoactivity, which means code as data. Language like Lisp or Conjure tests the program's code as a manipulable data structure. That means a AI writing in a homoaconic language can literally treat parts of its own logic like objects, edit them, analyze them, or build new ones dynamically. And here's an example. This function can be modified or be generated on the fly for another part of the same program. For self-aware AI, that's huge. It allows the system to think about thinking. Ref ref- Reflections let a program observe or even change its own structure at runtime, but this can get dangerous. If an AI messes up while editing its own code, it could crash or corrupt itself. So I propose transactional self modification. Basically, this test changes first and only commit them if they work. You can think of it like a Git branch inside the AI. It tries a new version of its planning module, runs some simulations, and only merges it into core logic if all tests pass. If not, it rolls back. This brings a new level of responsibility to software design, which not just debugging, where it teaches an AI to debug itself. Third, compares con, con, conspiracy, words are hard to pronounce. A conscious system will have dozens of processes running in parallel: perception, planning, self-learning, and so on. If these threads interface with each other, the AI could get mentally scrambled. That's why language like Rust or Erlang come in. Rust prevents race conditions at compile time, while Erlang uses isolated actors that passes messages. Both are great models for a conscious agent with multiple thoughts running at once. Pull all these together: homologicality, reflection, computacy, and transit, transactions, and you get a language toolkit for an AI that can safely learn and evolve by modifying itself. So, can a machine really be self-aware? I don't know really for sure, but I believe if we ever build one, it depends just how how so much on how we program it as what theories we believe. Choosing the right language features gives a clear, practical foundation for taking the first steps towards machine conscious. I believe when this gets figured out, this will change the world forever, just like when computers were first invented and just how ChatGPT came out a few years ago.
Right, thanks for sharing that. Why don't we just do a couple of questions? You talked about homo-iconic, I think. Um, can you give a better, I was having, I'm not that familiar with that term. So is that when the language can change itself, or what was that referring to?
Mhm. Yeah, it's a very interesting and kind of complex theory.
Yeah, because I could see that one thing I see, like, especially with the functional languages like Lisp, is that the code is a list. And then their main data structure is also a list there. So it's really easy to write Lisp code in Lisp or manage Lisp, code in, because again, it's all, everything's a list. The code is a list, and the only real data structure out there is a list there too. So yeah, I hadn't thought about that probably makes it easier for a program to self-modify itself. Then kind of reminds me, I was around back in the old days when Unix was being created. I wasn't involved in that, but I remember reading about it. And um, to make the Unix operating system was brand new operating system. They were starting to program this, Richie and Kearney, but they needed a programming language that was a little higher level than assembly, but could just still do what they wanted. And so they invented a programming language called C there to compile the operating system on. Uh, but again, they wanted to have, so you can, like, there's a compiler built into C, but the first time to do this, they had to bootstrap it because they they couldn't write the operating system in C because they didn't have a way of compiling C yet, and they couldn't compile C yet because they didn't have an operating system to write this. So they ended up having to write a compiler for C in another operating system that they had. I think it was like a DEC or PDP-11 or something. They wrote a compiler for C in that operating system, and then they compiled their new operating system, and then they booted their new operating system, and then rewrote the compiler for C. And then once they had the basics down, the C operating system is written. I mean, the Linux operating system is written in C, and it has a really good C compiler. So they could keep building once they had the basic structure in place. And I always thought that was interesting, sort of self-feedback loop that they were able to kind of create there. So have you ever done, the last question I have for you is reflection. Have you ever done reflection? I've only used it a couple times. It seems like that's where we, again, refer to code within code. Is that your understanding of what it is?
I just heard about it and I'm still trying to learn everything. It seems really interesting though.
Yeah. Yeah, because a couple times, like in Java, when I've needed to modify like some Java code in Java I think that's where I've used reflection. Last question, what kind of source, what was your favorite source of information for this?
I used a case of AI conscious language agent and global workspace theory the most.
So, all right. Well, thank you. Why don't we stop you sharing and I will share again. All right. Um, Feel free if you want to jump on Zoom. We'll Zoom Sunday night at 7 with a couple presentations. So feel free to Zoom, jump on there. And then remember our exam time, we'll do our presentations and we'll start at 8:30 on Tuesday here in the lab. Sound good? All right. See you next, at a future date.